Dear student, in this lecture we will discuss about the electronic configuration. We will elaborate the electronic configuration of 30 elements, the element whose atomic number starts from 1 to 13. So we will do electronic configuration of 13 elements. The word configuration is basically tell us about the arrangement of the electron in sub-energy level or in subshells. Please keep in mind that in atom there are basically different types of energy level, and these energy levels are known as shells. First energy level is known as K shell, second is M shell, third energy level is N shell, fourth energy level is N shell, and fifth energy level is O shell, and so on. Dear student, every shell has subshells. K shell has the first shell, it has one subshell. Uh, Similarly, L shell is second shell and it has two subshells, one S2, two S2, two S2, and two P6. Similarly, M shell is third shell. It will have three subshells. These subshells will be 3s2, 3p6, 3d10. Similarly, N shell will is a fourth shell and it will have four subshells. These subshells will be will be 4s2, 4s2, 4p6, 4d10. Similarly, N shell will is the fifth shell and it will occupy. It will have five subshells. These subshells are 5s2, 5p6, 5d10, and 5f14. So now, dear student, please keep in mind that every subshell has ability to accommodate maximum number of two electrons. Similarly, P shell as a subshell has ability to accommodate maximum number of uh, 6 electron. D shell has ability to accommodate maximum number of 10 electron, and F subshell has the ability to accommodate maximum number of 14 electrons. Every shell every shell has subshells in it, and similarly every subshells have orbitals inside it, and every orbit has the ability to accommodate maximum number of two electrons. So in S shell there are two electrons, so it is only one. This means that S shell subshell have only one orbit, and this orbit can accommodate maximum amount of two electrons. The spin of electron must be opposite. Similarly, in case of p subshell, it has can accommodate 6 electrons. So this means that p subshell will have three orbitals, 1, 2, and 3, and these three orbitals can accommodate maximum number of 6 electrons inside it. In case of uh, D subshell, D subshell have ability to accommodate maximum number of 10 electrons. This means that D subshell must have 5 orbitals, 1, 2, 3, 4, and 5. And each orbital has maximum ability to accommodate 10 electron, and the spin of electron must be opposite to each other. So maximum electron this D subshell can accommodate are 10. Similarly, in case of F, in case of uh, F subshell, sorry, in case of F subshell, F subshell has maximum number of electron 14, so F subshell must have 7 orbitals. 1, 2, 3, 4, 5, 6, and 7. And maximum number of electrons that F shell can accommodate is 14. So these electron, if F shell can accommodate maximum number of electron, then the electron will be paired in a spin up and in spin down state, and the number of electron will be 14, like this. The maximum so number of electron will be 14 in F shell. So now question here arises is that how we can determine that which subshell has a higher energy, or which subshell is basically a electron, which electron will occupy which shell. Basically, the occupancy of electron in different subshell is determined by a rule, and that by two rules, and these rules are known as Aufbau principle and N plus L rule. So now the student, according to Aufbau principle, electron prefer to occupy low energy levels, or electron occupy low energy levels. So now how we can determine the low energy levels? Low energy levels are determined on the basis of N plus L rule. If the value of N plus L is high, then this means that the value of energy is high. So this means that electron has higher energy and it will occupy high energy level. So N plus L is directly proportional to the energy of the energy level. Student, please keep in mind N is basically it is a principal quantum number, and whereas L is azimuthal quantum number. N is principal quantum number and whereas L is azimuthal quantum number. So now as we know that atom has subshells, and these subshells are like 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 4f14. So now how which orbit has which suborbital has higher energy than the other one, that is determined by the value of N plus L of these subshells. So now let us determine the N plus L value for all these subshells. We have 1s2, 2s2, 3s, sorry, 2p, 2p6, 3s2, 3p6, 6, 3d10. Let me clean this one. 4s2, 4p6, 4d10, 4f14. N plus L value for these will be 1s2. So basically, dear student, please keep in mind that 1, integer 1, 2, 3, 4, and 5, basically they are indicate a principal quantum number, value of principal quantum number, whereas the value of azimuthal quantum number L is basically varies, and L the value of L for S shell is 0, P shell is 1, D shell is 2, and F shell is and F shell is 3. So these are the value of principal quantum number. So now if we incorporate the value, we can get that 1s2 value of principal quantum number for 1s2 is 1, and whereas the azimuthal quantum number is 0, so we will get 1. Principal quantum number is 2, azimuthal quantum number is 0, so we will get n plus L2. Principal quantum number is 2, azimuthal quantum number is 1, and so we will get n3 value 3. Principal value of principal quantum number is 3, value of azimuthal quantum number is 0, so we will get 3. Value of principal quantum number is 3, value of azimuthal quantum number is 1 for p, so we will get 4. Principal quantum number 3, azimuthal quantum number 2, so value is 5. Principal quantum number is 4, azimuthal quantum number is 0, so we will get 4. Principal quantum number is 4, and azimuthal quantum number for p is 1, so value is 5. 4 plus principal quantum number is 2, value is 6. Value of principal quantum number is 4, and azimuthal quantum number is 3, so 4f14 has a higher energy value. So now, on the basis of, dear student, on the basis of energy, let's write them. And so we can write that 1s2 has less energy than 2s2. Now, interesting question here arises that the value of 2p6 n plus L value of 2p6 is high is same as n plus L value of 3s2. But according to Hund rule, an orbital or subshell having a higher value of principal quantum number will have higher energy. This means that 3s2 has higher energy than 2p6. So we can write 2p6 has lesser energy than 3s2. Similarly, the value of 3p6 is 4 and 4s2 is 4, but 4s2 quantum number is high, so we can write 3p6 and 4s2. Similarly, the value of 3d10 is same as 4p6, but principal quantum number 4p6 is high, so we can say that 3d10 subshell has less energy than 4p6 subshell. And similarly, we will write 4d10 have lesser energy than 4f14. So in this way, 4f14. So basically, in this way, electronic configuration is done in an atom on the basis of the energy of subshells. Basically, electronic configuration is done, and that tell us that which orbital will electron occupy on the basis, which orbital or which subshell electron will occupy in atom on the basis of energy. We can use here a trick, and in trick we can say that an atom has orbit one s orbit in K shell, and similarly it has two s and subshells. Similarly in L shell, similarly in KL, and in M shell it has three subshells. These subshells are 3p, 3p and 3d10. Please keep in mind that S shell has ability to occupy subshell has ability to occupy 2 electrons, and similarly P shell has subshell has ability to occupy 6 electrons, and D subshell has ability to occupy 10 electrons. Similarly, N shell has ability to have 4 subshells. So these subshells will be 4s2, 4p6, 4d10, 4f14, and O shell has 5 subshells. These could be 5s2, 5p6, and so on. Now we can use a trick in order to determine the energy of uh, uh, the orbitals in a shell, energy of the subshells in orbital. So first draw a horizontal, a vertical line like this with the angle of 45, somewhere around 45, and similarly draw second line, similarly draw third line, similarly draw fourth line, similarly draw this line, and similarly draw. So basically, dear student, this lines, the first line which we draw is basically representing 1s2, so we can write 1s2. Second line is drawn from 2s2, so we can write 2s2. Third line is drawn from 2p6, so we will write 2p6 and 3s2, and it's in the fourth line is basically it is drawn from 3p6 and end at 4s2. We can write like this. And fifth line start from 3d10, goes toward 4p6 and then 5s2. And fifth line basically start from 4d10 and end into 5p6. So basically this indicate that the energy of the orbital energy of the subshells are increasing in this fashion from 1s2 toward the 4p6. So this arrangement is basically used for the electronic configuration of different elements. So now let's start to perform the electronic configuration of elements from having atomic number 1 to atomic number 13. So now students, let us start the electronic configuration of an element from having atomic number 1 to atomic number 30. First element of periodic table is hydrogen and its atomic number is 1. So hydrogen atom, the configuration of hydrogen atom will be 1s1. Next atom is helium and atomic number is 2. The configuration for helium will be 1s2. S shell has the ability to accommodate maximum number of 2 electrons. So helium has 2 electrons, so they will be accommodated by 1s2 subshell. Next element is lithium. Lithium has atomic number 3 and it will accommodate 1s2 subshell and as well as 2s 2 subshell. Keep in mind that helium has 3 electrons, so 2s2 will become 2s1. So s2 subshell will accommodate 1 electron. Similarly, beryllium has atomic number 4. So beryllium will occupy 1s2 subshell and 2s2 subshell. The maximum amount of electron in beryllium are 4. Next one is boron, and boron has atomic number 5 and it can the electron in boron will occupy 1s2 subshell, 2s2 subshell, 1s2 and 2s2 subshell make 4 electrons, and then there will be a 2p subshell and 1 electron is remaining, so that will be filled by 2p subshell. Similarly, there is carbon, carbon having atomic number 6. So carbon, the electron in carbon will occupy one s2 subshell, two s2 subshell, and two p2 subshell. Similarly, nitrogen has atomic number 7, so electron will occupy one s2, two s2, two p3 subshells. Similarly, oxygen having an atomic number of 8 will occupy subshells like 1s2, 2s2, 2p6. So now these configuration may be represented diagrammatically, like hydrogen atom has one electron and it is occupying one S subshell. So this means that hydrogen has only one subshell, and that subshell is basically S subshell, and it will have electron. An electron could be in spin up state or spin down state. It could be in any kind of states, depend on situation. So it could be in spin up or spin down state. In case of if we consider carbon, carbon has 6 electrons. So 6 electron, it has the electronic configuration of carbon is that it has subshell 1s2, 2s2, and 2p6. So S subshell has an ability to accommodate 2 electrons. So one S shell will accommodate electron having opposite spin and 2 electron with opposite spin. Similarly, 2s2 subshell is also filled, and it will has ability to fill 2 electrons. So it will fill 2 electrons, but the spin of electron will be in opposite direction. Whereas the p subshell has ability to accommodate maximum number of 6 electrons. So p subshell have 3 orbitals. Because every subshell has orbitals, and orbital can accommodate maximum number of 2 electrons. So for 2p6, where the p subshell has 6 electrons, so it will basically accommodate, it will have we have 3 orbitals. In case of carbon, carbon has sorry carbon dear student, carbon has six carbon has 6 electrons, so 2p subshell have 2 electrons. So these electrons will be present in same spin in 2 orbital of the carbon. Now please keep in mind that according to Horn's rule, electron will initially be present in a form of a SAM spin, and when the SAM spin are completed an orbital spin, then opposite spins of electron can be incorporated inside the orbital of the subshells. So in carbon there are 2 electrons, so the spin of the electron in carbon p subshell will be either spin up like this, and it could be either spin down. Please keep in mind that the orbital energy in p subshell is same, so we can write anywhere spin of the electrons. An electron could be present anywhere in these orbitals, but the spin of orbital will be same, and it will be parallel.